Hi, everyone. I will show you operation of Femtet. Analysis condition settings, CAD import, run solver, and results display. Today's analysis model is array antenna. In this model, IC is placed in the center of the substrate, and dipole antennas are placed 3 by 3 on substrate. I will demonstrate multiphysics simulation of electromagnetic, thermal, and mechanical stress. And I will examine the results of electric field, directivity, temperature distribution, and deformation of substrate. Okay, let's start demonstration. First of all, analysis condition settings. Select 3 solvers for multiphysics: electromagnetics, thermal, and mechanical stress. Set analysis conditions for each solver. For example, set the frequency for electromagnetic and reference temperature for mechanical stress. Import the CAD model. Select CAD data from the folder. Next, material property settings. Substrate is dielectric. In this analysis, set the permittivity, thermal conductivity, coefficient of expansion, and Young's modulus. IC is dielectric. Set silicon and heat amount to IC. Set the air to this model. Next, set metal to each dipole antenna. Select all dipole antennas and set copper. You can use the data from material database built in Femtet. You can set the data of your own. Boundary condition settings. Set power port boundary to dipole antennas. Set an integral path and port impedance. Set open boundary condition to air. Outer boundary condition settings. Apply the room temperature and natural convection. Set feeding point of power. Model creation is done. Next, run the measure in solver. Calculation is finished. Let's examine the results. Examine the electric field by animation. You can see the electric field is generated from each antenna. Examine directivity in 3D. You can see the beam forming like this. Examine temperature distribution. You can see the temperature is higher in the center area of substrate by IC. Finally, examine deformation of substrate. You can see the substrate is deformed by temperature distribution. In this model, the impedance must match the resonant frequency of the antenna. Otherwise, current will not run in the antenna. So, proper analysis setting is important. Left figure is proper setting of impedance matching, and right figure is not proper setting. Left figure shows the current is flowing, but the right figure shows current is lost due to mismatching. The loss of current generates heat in the substrate. This figure shows the temperature distribution. Overall temperature of proper setting is 70 degrees. But if the setting is not proper, the overall temperature is 110 degrees. If the temperature goes higher, the substrate will be bent. This is comparison of displacement of substrate. If the setting is not proper, the degree of displacement is almost twice the proper setting. This displacement may cause the cracking of the substrate or antennas. To avoid these kinds of problems, our software Femtet helps you to optimize the overall design.